welcome to my third video in the series about explaining motion, and today we're going to be looking more at velocity time graphs. So last video we finished by looking at specifically distance time and then speed time graphs, and today we're going to look more into detail at velocity time. And so if you remember back from last time, we were able to calculate the acceleration. So if you remember that the acceleration is the change in velocity over the time, and so if we were looking at this value here, you have a change in velocity. It's gone from 0 through to 1.5, and so the change in velocity would be 1.5, and then it's taken 4 seconds to do that. So in this case our acceleration will be 0.375, and that will be meters per second, which is the units there. And so that's just another reworking of that, and so we can establish that the acceleration is the gradient in this case. Now if we were looking at the green line here, and that's slightly different, and so what that shows is a deceleration, and because what's happening is it's travelling at 1.5 meters per second and then it's slowing to 0. And so if we looked at this, the change in velocity for this would be negative 1.5, because the velocity is decreasing because the line is going down. That's a negative value. And all these values here mean v and u. V means, in this case, the final velocity, and u means the start velocity. So in this case, if your final velocity here is 0 and your start velocity is 1.5, then 0 minus 1.5 gives you the negative 1.5. And so here it takes 4 seconds, and so therefore your acceleration will be negative 0.375 meters per second, and so that's a deceleration. So any negative values that you calculate for an acceleration must be a deceleration. So one thing that critically makes a velocity time graph different to a speed time graph is that velocities can have negative values, and so they can act in 2 dimensions. In this case you can tell how quickly something is happening, and you can also tell in what direction. And so you can get values for velocities below the x-axis. Now if I was to explain exactly what's happening at each point, this red line here shows the car accelerating in a positive direction. So let's say the car can only move left or right, and we pick the left movement to be our positive value. And what's happening here is the car is accelerating away from that point, going left, and so it's accelerating. Here what it shows is it's still moving left, but it's slowing down, and so it's decelerating. What this section of the line shows below here, this shows it moving right, so in our negative direction, and so this shows it accelerating going right, and this section here shows it decelerating, but again still going right. So here we have a couple of scenarios with a car showing the difference between velocity and displacement. So they're going to mix them up, and we're going to show the motion and then show the differences between the 2 graphs. So in this case, what you've got here is a car moving at constant speed, or constant velocity, and therefore the one on the left, this one is our displacement, or sorry, our distance time graph, and this one here is our velocity time graph. Another example here, I'm going to mix this one up again, and so the car here accelerates and then slows down. If we watch that back again, it accelerates and then slows back down. And so this one on our left here, that will be our velocity time graph, so accelerating and then decelerating, and in our displacement or distance time graph is it's increasing in speed, so acceleration, and then levelling off and slowing down. The next one is slightly more tricky. So in this instance, and if you watch the motion of the car, it moves forwards and then it moves backwards, so it accelerates and then it goes back in the opposite direction. And so this is clearly our velocity time graph, and this one's our displacement. And so looking here, the object has accelerated away, and so it's got quicker, and then it's decelerated, so it's slowed down. It's then come back in the opposite direction and accelerated, and then decelerated, and hence the forward and backwards movement. This final one, they're not going to draw the graph, but they're going to show you the motion of the car. So if you watch the motion of the car and what happens, It goes forwards and then backwards and then forwards and then backwards, forwards and then backwards. That happens 3 times, and so our displacement graph would look something like that. Up and down 3 times, corresponding to the 3 movements backwards and forwards, and a velocity time, that's 1 forward and back, 2, and then 3.